My seminar is based on the topic Inverters and Converters in Electric Vehicle, guided by Ms. Anujoti, Assistant Professor of ECE Department. Moving on to the content slide, I have included introduction, history, and overview of electric vehicle powertrain, placement of converters and inverters in electric vehicle, inverters, converters, type of inverters and converters, advantages and disadvantages of inverters and converters, key factor in the designing of inverters and converters for electric vehicle, emerging innovations, future trends, tandem unit, companies involved, conclusion and reference. Moving on to the introduction. A rapidly growing market of electric vehicle. That is, electric vehicle market is one of the most booming market in recent years. This is the graph that showing the growth of electric vehicles and hybrid vehicles in recent years up to 2020, reported by World Economic Forum. Role of inverters and converters in electric vehicle. Inverters and converters are the fundamental components in an electric vehicle. Knowing the functions and significance of these components are crucial for optimizing the efficiency, performance and sustainability of EV. Moving on to the histories. Thyristor inverters were used in electric vehicle while DC to DC converters were used to convert battery voltage in 1900. Thyristor inverters were commonly used in EV at that time, and due to the less efficiency and high thermal uh, production, thyristor inverters are not used in coming EVs, so new inverters were invented. In the year 2000, IGBT inverters, that is insulated gate bipolar transistor inverters, become the dominant type of inverters in EV due to their higher efficiency, that is 90 to 95%. Thyristor inverters in 1900 produced 80 to 90% inverter in efficiency. In the coming year 2010, silicon carbide inverters were introduced offering even higher efficiency, that is 95 to 98% and power handling capability than IGBT inverters. Multiple stage DC to DC inverters were developed, that is single stage, two stage and three stage converters were developed. And coming to the year 2020, GaN inverters, that is gallium nitride inverters, were introduced, that is it will produce a efficiency of 98% plus efficiency. So GaN inverters begin to be used in high performance vehicles, that is Porsche Taycan and Audi e-tron. That is GaN inverters were cost high, so it can be only used in high performance vehicles due to its cost. And in coming the year 2023, GaN inverters expect to become more widely used in EVs as they become more affordable and reliable. Moving on to the next slide, that is an overview of electric vehicle powertrain. First one is the thermal system cooling. The thermal system cooling is used to cool the traction motor and other systems that produces thermal in the working. And the next one is a DC to DC converter, which will transfer one level of DC to another level for the use of local components like headlight, tail lamp, and audio systems that will work under 12 volt or 12 to 15 volt. Next is a power electronic control unit. That is the main brain of the electric vehicle that will control all the systems in an EV. Next one is the electric traction motor, which produces the power to the wheel. That is the main motor that will take the power from the AC to convert the power to the wheels. Next is a auxiliary battery. That is the battery for local loads, that is headlight, tail lamp, etc. That will produce the range of 12 to 15 volt on working. Next one is the onboard charger. The onboard charger contains an AC to DC and a DC to DC system for producing the power to the battery, and there are also systems with off-board charger, that is the vehicles without onboard chargers, and the transmission system, that is the power from the motor and transmit to the vehicles through transmission, and it cannot be transmitted without the transmissions. and a charging port for charging the vehicles. Next one is a traction battery backup. That is the main backup that is used for storing the electricity and for the transportation of the vehicles. Moving to the next, battery backup stores the electric energy that power the vehicles. Inverters convert the DC voltage from the battery pack to AC voltage required for electric motor. Converters DC to DC converts high battery voltage to lower voltage for vehicle components. Electric motor convert the AC voltage from the inverter into mechanical energy to drive the vehicle. Next is the transmission transfer the mechanical energy from the electric motor to the wheels. And a motor controller in EV controls the inverter to generate desired AC waveform to electric motor. And a block diagram that shows how the power transfer from battery pack to wheels, that is battery backup, inverter, motor controller, electric motor and a wheel. Moving on to the placement of converters and inverters in electric vehicle. There are two types of arrangement mainly in EVs, that is an with onboard charger and without onboard charger. That is the system with AC to DC and a DC to DC in the vehicles will called onboard charger and without called offboard charger. The advantage of an onboard charger is the EV can be plugged into any sort of grid which can be which power supply can be produced, and without onboard charger the vehicle can only be connected to the grid that is specifically designed for this EV. And looking to the placement of other components, that is the battery backup is situated at the placed at the bottom of the vehicles, and a BMS is placed near to the battery pack. The BMS means the battery management system, mainly a control unit for a battery that contains the safety, that is overcharging, over discharging, overheating, short circuit, and the battery percentage, cell balancing. These are all controlled by the battery management system of a battery. And the next block is a DC to DC that's situated near to the BMS, and for reducing the length of DC cables to reduce energy losses. Next one is a DC to AC that located placed near the motor for reducing AC cables to reduce the energy and energy losses. And also DC to AC are sometimes integrated with the motors for reducing the energy losses. And next one is a motor and a differential. Differential is used to transmit the energy from the motor to the wheels. Moving on, the inverter. An inverter is a key component of the EV powertrain. It converts the DC voltage from the battery backup to the AC voltage required for the electric motor. The inverter uses semiconductor switches to control the flow of current from the battery pack to the inverter. The inverter can also be used to control speed, torque of the electric motor by adjusting the frequency and amplitude of AC waveform. The inverter can be used to accelerate and decelerate the vehicle. Inverters are also important for improving the efficiency of EV powertrain by converting DC voltage from the battery pack to the AC voltage required for electric motor. The EV can reduce the losses associated with the AC to DC conversion. That is, the inverter is one of the crucial component in an EV powertrain. That is, it converts the DC to AC used for electric motor, and the waveform produces from the AC waveform will determine the power control of motor. That is, we can vary the control of motor by varying the frequency and amplitude of the waveform, and how much efficiency will be increased in the inverters will affect the overall efficiency of the EV powertrain. Next, moving on to the converters. Converters are the power electronic devices that convert DC voltage from one level to another level. In EV, converters are used to reduce high voltage from the battery pack to low voltage for other components in vehicles like local loads, as I already mentioned, headlight, tail light, local loads, audio systems, etc. Converters are important part of EV powertrain because they allow the battery pack to power all the vehicle electric efficiently and reliably. Converters are lighter and less expensive than transformers, which can help to reduce the weight and cost of the EV powertrain. Converters can help to improve performance of the EV powertrain by providing a stable and regulated voltage supply for other components in the vehicle. That is, here mentioned other component in an electric vehicle means, for example, a contactor. The contactor works on input supply 12 voltage. That input supply is connected from the DC, step down DC voltage. Moving on to the next slide, that is type of inverters and converters. Talking about the type of inverters and converters, there are different type of inverters and converters. Mainly it can be divided into three. That is voltage source inverter. Voltage source inverters are commonly a type of inverters in EV, and current source inverters are less common in than voltage source inverters, but they offer advantages such as improved efficiency and reduced switching losses. That is, it produce around 85% efficiency. Multi-level inverters. Multi-level inverter is a type of inverter that uses multiple voltage level to generate AC voltage output. Multi-level inverters offer several advantages over voltage source inverters and control source inverters, such as improved efficiency. That is, it provides an efficiency of around 90 plus efficiency, reduced switching losses, and reduced electromagnetic interference. Type of converters: buck converter, boost converter, and flyback converter. Buck converter are commonly used in EV to reduce high voltage from the back to lower voltage. And talking about the boost converters are commonly used in EV to increase the voltage from battery pack to higher voltage for certain components. And flyback converters. A flyback converter is a type of DC to DC converter that uses a transformer to convert the voltage from a DC source. Flyback converters are commonly used in EVs to convert high voltage from the battery pack to low voltage for the other components in an electric vehicle. Next is the advantages of inverters and converters. Advantages of inverters and converters are control motor speed and torque. That is, it can control the speed and torque of the motor by varying the frequency and amplitude of the AC wave coming from the DC to AC converter, and improved efficiency. That is, by increasing the efficiency of an inverter, the overall efficiency can be increased. Reduce noise and vibration. That is, how much smooth and continuous the waveform is, it can lead to reduce the noise and vibration in an EV. And the advantage of converters is convert different voltage level and current level. That is, it can convert higher level to lower level and lower level to higher level, and it will also improve the overall efficiency of EV and reduce size and weight. That is, the minimum EV comes with a shoebox size and a weight around 10 pound. Improved reliability. That is, the reliability can be improved by using high reliable converters. The disadvantages of converters and inverters are heat generation, because the heat generation comes with a high disadvantages, because due to heat generation high amount of energy can be losses. And electromagnetic interference. That is, electromagnetic interference defines that the ability of an electrical component to work in an electromagnetic environment. That is, it can work without changing the efficiency and performance in an electromagnetic environment. Complexity. Converters and inverters are complex devices that requires careful design and control. Cost. Converters can be expensive, especially silicon and gallium nitride transistors. The cost of the transistors and inverters are highly depending on the cost of EV. That is, the most advanced technology is the GaN inverters. The GaN inverters are now produced for lower vehicles for affordable, because the GaN inverters laterally produced for only high performance vehicle, and its cost are high, which cannot be affordable by the lower people. And failure rate. Converters can fail, which can lead to breakdown of the EV. Any converters that leads to a fail which will not move the EV, that can cause a total overall failure. Moving on to the key factors in the design of inverters and converters for electric vehicle. First one is the efficiency. Talking about the efficiency, the one that designs the EV should consider about the efficiency of the EV because the higher the efficiency of the EV, it can lead to higher drive range, which is the main component in a transportation vehicle. Next is the power density. Inverters and converters need to be able to handle high power output, but they also need to be lightweight and compact. Next is the cost. It is important to design inverters and converters that are cost effective to produce because by increasing the amount of EVs in the market, then only we can reduce the cost of overall EV and the robustness. That means it wanted to be work in high harsh environment. Next is the safety. The safety consideration should be the first. That is, the passengers and drivers should be safe in an EV because the heat can produces a fire in the EVs. The newses in the later are the data that we should be considered. An additional design consideration, that is type of motors. Induction motor require a different inverter and converter than permanent magnetic motor. Desired performance characteristics, that is top speed, acceleration, range. Available battery technology. Lithium-ion batteries have different requirement than lead-acid batteries. Then moving on to the emerging innovation, that is silicon carbide and gallium nitride inverters. The most efficient inverters are silicon carbide and gallium nitride, which is the gallium nitride is the most efficient that produce 98% plus efficiency. And next is a modular inverter. Modular inverters are type of inverters that of multiple smaller inverter module. Modular inverters offers a number of advantages over traditional inverters, including improved reliability and scalability and flexibility. Next one is the digital control. Digital control is increasingly being used to control inverters and converters. Digital control offers a number of advantages over traditional analog control, including improved performance, flexibility, and diagnostics. Next is the integrated power electronics. Integrated power electronics is a new technology that combines power converters and motor controller into a single unit. Integrated power electronics offers a number of advantages over traditional systems, including reduced weight and complexity, improved efficiency and cost. Integrated power electronics is still in its early stages of development, but it has the potential to revolutionize the design of EV. Next to the future trend, that is vehicle to grid technology. This technology allows two-way energy transfer between the vehicle and the electric grid. Not only can the vehicle can draw the power from the grid, but it can also suppose excess energy back to the grid. That is, the vehicle grid technology is the most advanced technology, emerging technology. That is, it can provide the charge from the vehicle to the house or to the grid. That can be used in the time of power cut. That is, the car will be, it can be used as an equivalent of an inverter in an EV. It can produce the charge up to 1 to 2 days depending on the battery voltage. And improvement in efficiency and power density. Nowadays, the most efficient technology is innovations are leading for the highly efficient EV that can increase the power range, drive range of the vehicle. That is the main component in a transportation vehicle, leading to the tandem unit. Tandem unit is a power electronic system that uses two inverters connected in series, two or more inverters that connected in series to increase the output. That is, tandem unit key advantages are increased voltage output, improved efficiency, reduced size and weight, increased reliability. These advantages are the main key component of a component that we are looking for because of the how much the reliable size, reduced size and weight. Then we can increase the use of high voltage cells that can increase the drive range. And using the multiple inverters, it can increase the voltage output also by reducing the stress and also the reliability. Moving on to the companies involved are Bosch, Continental, Denso, Investens, On Semiconductors, Renaissance Electronics, Siemens, Texas Instruments, Visteon, and Yasaki. Next, moving on to the conclusion. Inverters and converters play a critical role in performance and efficiency of electric vehicles. Inverters and converters are being increasingly sophisticated with the use of semiconductor materials such as silicon carbide and gallium nitride transistors. As EV become more mainstream, inverters and converters are expected to be continue to evolve and become even more efficient and reliable. This helps to further extend the range of EV and make more affordable to own and operate. Thank you.